Every year my employer provides its employees with annual health screenings. I had one done just a few months ago, and in these health screenings you can measure key variables such as the height and weight, blood pressure, and BMI, as well as your body fat, your sugar, your total cholesterol, and your LDL cholesterol. And these are very good things to know for your overall health, to make sure that if any one of these numbers is trending upward, that you could take corrective action before it turns into something more severe, like a heart attack or a stroke or something like that. In the same way you can do for your health, you can also do for your cars. And that's what I've done here. I've got 2 sets of lubricant analysis reports. They look kind of funny because I cut out the personal information, but anyway, I've got one analysis report that was from the 1991 Mercedes 420 SEL that I ran during its shakedown phase. I've got the engine, transmission, and differential results here. And then over here on the right side, I've got the 95 Ford F-250 that I'm making a video series on during its current shakedown phase, and I've got the engine, transmission, transfer case, differential, and power steering results here. And if you view my channel regularly, you'll know that I'm currently doing a series on the F-250 to try to show you guys what I do when I get a used vehicle. And one of the very first things I do is I change all the fluids front to back. And the reason I do that is because it's an unknown. You don't know if the owner changed any of those fluids and what kind of fluids that he used. So this is a very good way to determine exactly what it is you have from an analytical perspective. So the first reports that we have here is going to be the engine. We got the Ford has a 351 Windsor engine in it, and the Mercedes has a 4.2 liter single overhead cam engine. And if you looked at the oil change video that I made on the F-250, one of the first things I noticed was the crankcase breather element was completely missing, as well as the hose had a significant crack in it. So this engine was ingesting, or it looked like it was ingesting, a lot of dirt, and the fluid analysis report backs that up analytically, because the high silicon, sodium, and potassium values basically tell you that dirt was getting in the engine in some fashion. And we already know how that was happening, and that problem has already been addressed and fixed. So I know that the future analysis of the oil will come back with numbers a lot lower, but as a result of the increased dirt ingestion into the engine, we have elevated levels of lead and tin. And this basically means that it's coming off of the bearing material. Bearings are made, in a lot of cases, they're tri-metal bearings. They're made out of lead, tin, and copper, kind of like a Babbitt material. And the lead is the first thing that wears first. It sacrifices itself and has good properties such as embeddability for particles. Over here, with a vehicle that was normally maintained, look at that. You have hardly any bearing wear whatsoever with this. And you also have very little dirt ingestion. So these numbers are directly related. The more dirt you're going to have, the more wear you're going to have. And if you look over here with the iron values, 15 and 10 parts per million, very low compared to the 54 parts per million. On the Mercedes, the first oil that was used, it came with a Mobil 1 1550, and I converted it over to an AMSOIL 10W40. Both very good oils, and so we have relatively consistent wear numbers across the board. Over here with the Ford, we had a petroleum-based 5W50. I want to say it was Valvoline conventional motor oil. And these values here are incorrect. The oil didn't have 150,000 miles on it. The truck does, but the oil had around 7,500 miles on it. Still way too long to go on a regular petroleum oil. So because I changed the oil, converted over to a synthetic and a higher viscosity grade, and also repaired the PCV system properly, I'm expecting these numbers to go ahead and trend downward during the next analysis. But had it not been so obvious that the truck had an inoperative PCV system allowing dirt to get ingested into the engine, and you just strictly did the oil analysis, it would have come back like this in the same fashion, and you would have known right away that you needed to look at the potential sources of the dirt ingestion. Maybe you've got a bad air filter, or a crack in the air filter housing, or PCV system, or something like that, or a bad gasket somewhere. So it's always good to do not only a good visual inspection like I did when I first got the truck, but also to back that up with the analytical reports and see exactly to what degree this problem here has caused problems internal to the engine. And these values might look high, and for an engine they technically are, but the tests that they use when they analyze the lubricants are very, very sensitive. So we're talking parts per million. And the way I like to look at it is, if you're talking about money, if I were to give you $114, that's nothing compared to $1 million. So we have 114 little teeny tiny particles of lead per 1 million particles. So it doesn't mean that the engine's about ready to let go or anything like that, but it does tell you that you need to be on alert and fix this problem before you do start having problems like a rod knock. Over here you have your iron value, which is basically your cylinder walls. You have chromium over here, which is typically your piston rings. They're fairly low and normal. And you have aluminum, which in a lot of newer engines would be your cylinder heads, but in the Ford's case it's got cast iron heads, so that's basically just parts like the intake manifold, water pump, those kinds of things. Oil cooler maybe, for copper and aluminum. Over here's the foreign particles, like dirt, and silicon, like road salt or sodium. And then over here you have your additive metals, your phosphorus and zinc, also abbreviated as ZDDP. That stands for zinc dialkyl dithiophosphate. That's the main anti-wear additive found in the majority of lubricants. And right away, looking at these values here, you can tell that this is a API-SN or SM oil. If you look over here to the AMSOIL and Mobil 1, you can see you've got much, much higher values of the anti-wear additives. And that's very important. I don't really think that these values here, the API, SN, and SN specs, are really capable of protecting your engine over the long term. And these results somewhat verify that, although these numbers are inflated because of the dirt ingestion problem. But I went ahead and switched this truck over to the AMSOIL high zinc formula for that very reason. And I recommend you guys do the same. Use a high zinc product in your vehicles, especially if you have flat tappet cams. Over here toward the bottom we have a test here that can test for antifreeze or water in the oil, and that value is negligible, so I know that the head gaskets on that engine as well as the heads were in good shape. If this number were any higher than that, I would definitely have to start looking at potential sources of that. Maybe a leaking oil cooler or head gaskets, those kinds of things. The viscosity measured in centistrokes at 100 degrees Celsius or 212 Fahrenheit is a little bit low, or actually a little bit high, for a 5W30 oil. So this oil is now out of grade. It's starting to thicken. And we have a viscosity chart over here. So a 30 weight should be between 9.3 and 12.5, and we're 13.7. So that puts me into the 40 weight category. So this oil is starting to break down. It's starting to get thicker and thicker and thicker. The base number here, or total base number, or TBN, is a measure of the reserve alkalinity of the oil. And what this number is it means it's how many grams of potassium hydroxide or milligrams of potassium hydroxide you have to add to the oil to make it neutral. This is very low, whereas over here on the other oil that was changed more frequently, we have much higher values of the total base number. And basically this measures the ability of the oil to neutralize the acids that are in the oil just as a normal part of the combustion process. Usually nitric acid for gasoline engine or sulfuric acid if you have a diesel engine. And these values here, oxidation and nitration, are just measurements for how oxidized the oil is as well as how acidic the oil is. So on the one hand we have the oil's reserve alkalinity capability, and over here we have how acidic the oil actually is. Trending downward a little bit, these aren't good values, but definitely not in the critical phase, which is good. Overall, the engine, this tells me that the engine is in good shape, and I'm fairly confident that I've addressed the wear problem with the PCV repair, and switching to a thicker oil with a higher concentration of anti-wear additives. So I think I've preemptively addressed any concerns I found in here, but it just goes to show you the differences between a vehicle that was properly maintained with high quality lubricants, Mobil 1 here and Amsoil here, versus a vehicle that was basically averagely maintained, somewhat neglected, with regular conventional oil that is not capable of extended drains like these other lubricants are. The Mercedes engine basically has no wear going on, particularly in the bearing area. Not so much the case with the Ford, but that's not Ford's fault. I'll go ahead and take another sample of this when I change the oil about a year from now, and I'll make another presentation of those results, and I would expect all these numbers to fall back down much more close to what these values are. At least that's the expectation anyway. Hopefully that'll be proven out. So now we'll move on to the transmission, which is basically a hydraulic system in its most basic form. So the analysis is a little bit different. So we have a little bit higher levels of iron than what's normal. This is basically your planetary gear set. 216 versus 32 for the Mercedes. But the transmission, this is not really a completely fair comparison. The Mercedes transmission fluid had 23,000 miles on it, and the transmission in the F-150, unfortunately, the fluid was never changed based on the condition of the fluid and the date code on the old filter. So this petroleum transmission fluid had over 150,000 miles on it, and it was 17 years old. So these results are not bad at all, considering the conditions under which this transmission was operated in. It's been in a heavy-duty vehicle with a towing package with regular conventional transmission fluid in there that was never changed. Perhaps it was topped off now and again, but there's no guarantee for that. But overall, the results really aren't all that bad. We have a little bit higher levels of copper, lead, and tin. There's some bearings inside the transmission, just like you have in an engine. The copper could come from cooler lines and also some of the clutch material, as well as the lead being in clutch material too. What we're looking at here are some of the elements that made up that sludge that I showed you on the transmission pan magnet in a very, very small form. Over here we have our contaminant materials, our dirt and sodium and potassium, and they're fairly low, so we know there's no problems there. And we have the additive materials, which compared to an engine oil are fairly low because the transmission fluid has a different chemistry, being a hydraulic fluid versus an engine lubricant. Our viscosity is somewhat low for this fluid. It's supposed to be a Ford Mercon 5 fluid, So we know this oil was starting to break down. Slightly acidic, but not even enough to worry about. Didn't even move the needle out of the normal range. So that's good. And not too much oxidation or nitration going on. So overall, I'm very happy with the transmission. You saw the video of the transmission fluid change, hopefully. The pan came out very, very clean, just a very small buildup of sludge in the pan. I saw no chunks of material there, and just the usual buildup of ferrous material on the pan magnet, nothing out of the ordinary. And this analysis report, although it does say abnormal, pretty much indicates I got to that transmission just in the nick of time. I don't think that I would have wanted to continue driving the truck with fluid like this. It was definitely time for a change. And one of the other things that the lab does is it gives you an explanation of all the flagged materials, or all the flagged values here. I don't know if you can read that. The camera I use, this older Sony Handycam, has an extremely narrow field of view, unfortunately. It's like an atom wide. So I've got to keep panning back and forth to get everything in, unfortunately. But overall, transmission's in exceptional condition considering the conditions under which it was operating and the level of maintenance or that lack thereof that it had. Most people just don't think about changing transmission fluid at all. It doesn't occur to them. But as you can see here, it's definitely something that's needed, especially when you consider how expensive a transmission is and how hard they are to replace. So now well, this is the differential for the Mercedes. The F-250 it's four-wheel drive, so it's got a transfer case, and I went ahead and had that analyzed as well too, and that came back a little bit less normal. One of the main things that we see here with the transfer case is we have a lot more dirt in there compared to the transmission, and I'm not sure how that transfer case is designed. There's probably a vent on there somewhere, and you know, maybe some insects got in there and started making a nest or something like that and put some dirt in there, or maybe it got in there from the factory. But just like the transmission, the fluid was never changed. 150,000 miles, regular petroleum fluid. So I'm not surprised that this number kind of increased over time as more and more dirt got in there and was never changed out. Iron levels are lower than what was in the transmission. These numbers are a little bit higher than I would have suspected, being a transfer case. But I don't know a whole lot about transfer cases, to be honest with you. I've never really rebuilt one. There probably are bearings in there, but I don't think there's any clutch material in there, so I'm not really sure where the copper would be coming from. But I can always read the explanation that they give to kind of point me in the right direction as to the sources of some of those materials. But I went ahead and changed that fluid anyway, and so we know we're going to be in good shape there. And next time I change the fluid, which will be about a year from now, I will expect these numbers to be much, much lower, because I also converted it to a synthetic fluid. Once again, we have our additive materials, and viscosity is still slightly low, so that oil is pretty old, but the acid number, oxidation, and nitration are right in the normal range, no problem there. So I know overall that the transfer case is in very good condition. You know, 161 and 220 might seem rather high, but we're still talking about 161 out of 1 million, so fairly low, but definitely worth keeping your eye on for sure. And next we have the rear differential, and this differential is the 10 1/4 inch limited slip differential, and just like in the transmission, 17 years and 150,000 miles on regular petroleum lubricant. We have pretty high values of iron, but keep in mind that differentials don't have any kind of lubricant filtration. So any kind of wear that goes on, it just churns and churns and churns inside the gearbox. It's got nowhere to go. So these numbers just keep trending upward over time, which is why periodic changes of the differential are recommended. And that was the case with the Mercedes. If you look at the Mercedes, we have much, much lower values of iron because that differential fluid was changed at regular intervals, I think every 25,000 miles. And that shows up analytically on these reports. So there's very little wear going on in that differential versus the one in the Ford. But that's not to say that that's because a Ford differential is inferior. It just basically says that this was never changed, and it goes to show you the importance of changing these fluids. A lot of people don't even know there's fluid in the differential, or even what a differential does. So I like to change mine about every 25,000 miles as well. We have a little bit higher values of silicon, but not terribly bad. Differentials, just like transfer cases, actually have a vent on them to equalize the pressures, and that's how the dirt can get in there. But I went ahead and changed that out anyway to get these numbers down and that number, and I also cleaned up the drain plug magnet, so that should be much more effective now. But unlike the Mercedes differential, the Ford differential is actually a limited slip, so there might be some materials in here that don't exist in regular standard differentials, such as copper, for clutch pack materials, maybe some nickels, things like that. I'm not really sure what the composition is. And then over here you have your zinc and phosphorus additives. Another additive you would have is sulfur, but that's not tested on here. That's why gear lube smells so unique and distinctive compared to other lubricants. Our viscosity is slightly low for a 90 weight gear oil. So that means that we've had some shearing going on. The actual lubricant would shear apart and start going down in viscosity. So I was definitely right in changing this. And it's slightly acidic, so that tells me that the oil is definitely getting long in tooth, very old. I've got no water in that differential, so that means that the truck, for a differential you might get water in there by driving through deep water, or in my case, backing a boat up down a ramp and getting that differential into the water too deep. You'd have water in here, and the fact that this is negligible tells me that that didn't happen, which is very good news, because you just don't know how the truck was driven when you buy it, and this actually tells you exactly what kind of shape everything's in. So overall, differential is not in bad shape at all. And next we'll go on to the last thing, and that's the power steering fluid. And of all the fluids on the truck, it's actually the fluid that's in the worst shape. So power steering over here. As you recall, I think I might have pointed out that power steering pump made a groaning noise when I first got the truck, and that's because it ended up being low on fluid, unfortunately. I added some more fluid in there, but for the most part, once you set up a wear condition like this, and you're actually wearing material away, and those tolerances get wider and wider, and those kinds of pumps, there's no way of going back. You can put synthetic fluid in there, you can put a filter in there, and it's not going to undo the damage already done, but what it will do is make sure the damage doesn't get any worse. And the truck runs and drives just fine. The pump is just a little noisy. I showed you the amount of lateral play on the pulley when I did the alternator video, so that's not good, but it's not to the point where immediate action has to be taken where I have to replace the pump or rebuild it. Definitely worth watching more closely. But I took corrective action on that and went in with a completely synthetic equivalent Type F fluid, as well as installed a inline combination paper and magnetic filter. So these numbers should be much, much lower the next time I change that out and have it analyzed. But 974 parts per million of iron in a power steering system is really, really high. especially when you consider the small quantity of fluid we're talking about in a power steering system. But I hope I got to that just in time. The steering is nice and tight on that truck still. The only problem is that the pump is a little bit noisy, which is perfectly livable. These values are yellow because the wrong type of fluid was identified. The lab thought it was a Mercon 5. It's actually a Type F for power steering, so these numbers are a little bit skewed. The chemistry is a little bit different between the Type F and the Mercon 5. Viscosity is a little bit low, indicating the age of the fluid, as well as the acid number slightly high, but still within the normal range. As well as oxidation, starting to get a little bit oxidized there, but definitely needed to be changed, and I'm glad I changed it to get rid of all that contamination right there, and went in with an inline power steering filter. So what we have here now is a complete health report of the entire drivetrain of that F-250 that I recently bought this year, September 10th, and I now have analytically a very good idea of the condition of all the components on that truck that make up the drivetrain, all the components that cost the most money. I now know where to focus my attention on next to prevent a breakdown or more serious problem. And a lot of commercial trucking companies rely on oil analysis for that very reason, to try to fix things before they break. And I do the same thing. I don't want to have to put a new engine in there or have the transmission rebuilt. Those are very costly things to have done. It's always better to know without a doubt what you have to start out with versus just looking at something and just assuming it's okay or listening to something. Those are all valid ways to evaluate the conditions of things, but it's also good to back up what you see and hear with actual numbers to get a really good idea of what you've ended up with. So overall, taking all these reports into their entirety, overall that truck is in very good condition. It's got good bones. I've converted everything over to synthetic oil and did all the proper PM on it, such as repairing the PCV system to prevent problems like this in the future. I think based on this and the corrective action that I've taken that I can get a lot of life out of that truck.